In the last video, we reasoned our way to pi, the relationship between these two lines. And now that we know there's a relationship here, we can use it to help us uncover other relationships. By the way, if you haven't seen the last video, I recommend watching that first. Let's see what happens when we cut both the circumference and diameter in half. Well, we end up with a butchered circle, but even though our circle doesn't look the same, these two lines still have the same relationship with one another. In other words, the relationship between these two lines is still pi. This is because both lines have changed in the same way. They've both been halved. Remember, pi is a constant relationship between the circumference and the diameter, so changing the length of one of these lines necessarily changes the length of the other. Even if this butchered circle looks different now, by moving the lines a little bit, we can see that there's still a circumference and diameter there, in the same proportions that we started with. In reality, cutting both lines in half just made a smaller circle. Okay, so we know that changing both lines in the same way preserves the relationship of pi, but what would happen if we only changed one line instead of both? First of all, let's get rid of our diameter line. Since it's double the length of our original radius line, cutting it in half just gives us back our radius. Now let's cut our circumference line in half again, but this time we're only changing the circumference. Awesome. So then what would be the relationship between these lines now? Well, we know this must change the relationship between our lines, because we only changed the circumference, so we can't have pi anymore. But that doesn't mean there isn't a relationship here. In fact, pi can help us determine what this new relationship is. See, because we cut the circumference in half without changing the radius, the circumference line is now half as long with respect to the radius line. So now the relationship between these two lines is half of what it was before, half of pi. We know this because all we have to do is halve the radius line as well, and we'll have pi back again, just like before. Likewise, if we go back to our butchered circle and double the circumference line, then the circumference is now twice as long with respect to the radius. So the relationship between these two lines is now pi doubled, because we'd have to double the radius line to get pi back again. Once we've figured this out, we can determine the relationship between the circumference and the radius at any length. And once again, because we're talking about pi, we still have a constant relationship between these two lines. It doesn't matter what the length of these lines is. Again, we don't care about measurements. No matter how big or small our circle is, the relationship remains the same for all circles, and we know this precisely because we've been ignoring measurements this entire time. All we've done is manipulate these two lines to find new constant relationships, and we call these new relationships angles. In fact, those fractions of pi came to be known as radians, which is the standard method of measuring angles in mathematics. You've probably seen or heard of radians in school, but for whatever reason it never really stuck. After all, the real world uses degrees to measure angles, so why bother with radians? Well, you wouldn't be totally wrong for thinking that. Our schools should be teaching us things that we can use in the real world, and degrees have been used in the real world for much longer than radians. Here's the thing though, there isn't really an elegant way to explain degrees. We aren't even exactly sure why numbers like 360 were used to describe the relationship of a radius to the circumference of a circle. But we do know that pi can be used to find angles without any arbitrary numbers, and when we do this, it actually allows us to discover other mathematical truths more easily. And that's exactly what we'll be doing next time. Hey everyone, thanks for watching ADD Philosophy. Don't forget to subscribe by hitting the logo in the center of the video, and be sure to share your thoughts or questions in the comments section. These videos are meant to make you think about math differently and ask questions, since I can't cover every facet of mathematics that could lead up to some of these concepts. Speaking of which, let me know if there's something math related that you'd like me to cover in a future video. Thanks again, see you guys later.